go. It's Mr. Dunn. I hope you're doing well. This is my first video on a new streaming setup. I bought a whole new computer to do this for you. So I hope it pans out and I hope the quality is really good. This is the first activity we did in the entire school year. So what I want to do is give you just one of the pages of these. That way you know how to do this on your own. In the top left box, you've got word problems. Top right, you have equations, tables, and graphs in the bottom. Your job is to fill out as much of this as you possibly can because all four of these boxes are what we call multiple representations of a function. And so in this first one, you've got a word problem given to you and basically nothing else. You and your friends go to the state fair. It costs $5 to get into the fair and $3 every time you go on a ride. What I might start by doing is go down into the table because we can actually use the word problem and kind of our own common sense to fill out this table. Because what that first row is representing right there, where it has a 1 in that row, is what would the cost be if you went to the fair and got exactly one ticket. And if you got exactly one ticket, yeah, it costs $5 to get in, and then, yeah, $3 for that one ride. We'd say y is equal to 8. 2 tickets would then cost you $11, 3 tickets, 14, and so on. You just want to watch out a little bit. It jumps you to a 6, so you can't just kind of follow the whole thing in order. 6 tickets then would be a total of $18 because we would do 6 times 3 plus the $5 to get into the fair. 18 plus 5 is 23. Or you could have followed the pattern and just went up by 3 twice to fill that in. Now, one thing you might want to notice, it gives you the graph. You might want to notice that actually all of these 1 and 8 pairs right here, these are ordered pairs that are graphed out to the right. We have 1, 8 right there. I'm not going to do all these. 4, 17 would be right there. 6, 23. So one thing you should notice in the representation with the graph is that whatever you filled out in the table certainly appears on the graph as well. Those points make a line. So just keep in mind, there's this parallel between those ordered pairs you could graph and the table that we fill out using the word problem's information. And so all we have left now to consider is an equation. We're going to try to use in y equals mx plus b format. You'll recall from at least later in the year, yes, we did this at the very end of August, but by September we were using this equation all the time. M represented slope, and b represented a y-intercept. The y-intercept is wherever our line intersects the y-axis. In this case, that happened at 5 on the y-axis. We know a 5 must go in that spot. Question is going to be what the slope is. We can do slope with rise over run. Easiest way to do that would be to look at the graph and try to find 2 points where we can count rise and run. Although looking at the graph, I'm not certain that's going to be that easy to do. We always want to find points where it actually lines up exactly on the grid lines, like 5 and 20 right here. And I'm noticing actually again that 10 and 35 is another one of those situations. In addition to the y-intercept we could use as well, because that's 0, 5. And between any of those, we're going to count rise and draw a triangle. We have to be a little bit careful. That's a rise of 15 because the scale on the left side goes up by 5s. And it runs by 5 squares, which are each worth 1, so it's a run of 5. We'd say rise is 15. Run is 5. That divides nicely. M is equal to 3. Back to our equation. Now we know the whole thing. Y equals 3x plus 5 is the equation. There you go. Hope you found that useful. And try the rest on your own. I think you have 6 more pages to try independently.